Welcome back to using double and half angle formulas. In this video, we're going to go through an example where we need to find the trig functions for half of an angle where we don't really know what the angle is, but we do know bits and pieces about it. Okay, so let's go ahead and give that a shot. Okay, so here we have a situation where we have another right triangle, and we are given an acute angle beta, and opposite angle beta we have an opposite side of 7, and adjacent to beta we have a side length of 24. All right, so with this situation we are asked to find sine of beta over 2, the cosine of beta over 2, and the tangent of beta over 2. Okay, so all we know is we have this right triangle where we're trying to find the exact values of half of angle beta. Okay, so again, we're going to start with finding the trig functions of beta. Sine of beta is cosine of beta and tangent of beta. Okay, so what do we know? Well, of these three, we know immediately tangent of beta is going to be 7 over 24, right? And then we're going to go ahead and solve for what we're missing, right? We're missing the hypotenuse here, so we can say a squared or 7 squared plus b squared or 24 squared is equal to c squared. And that's pretty easy to come up. So that's 49 plus 576. And that's going to be c squared is equal to 625. And since we're just dealing with a right triangle where we are looking for the hypotenuse, it's going to just be the positive square root of 625, which is 25. And once we know that that hypotenuse is 25, then we can say that the sine of beta is going to be 7 over 25, and the cosine of beta is going to equal 24 over 25. Okay, fabulous. Now we can move on to actually finding the sine of beta over 2, the cosine of beta over 2, and the tangent of beta over 2. All right, fantastic. Let's look at those formulas. Well, they all kind of look the same, all right? Sine of beta over 2, we know is going to use this formula, plus or minus the square root of 1 minus cosine of beta over 2. Now, the plus or minus is going to come into play when we're dealing with something in the plane. When we're dealing with just something that's a right triangle, we know that angle beta is an acute angle, which means half of angle beta will also be an acute angle. And so we can say that all of our trig functions will end up being positive. That won't always be the case, as we'll see later. But since this is going to be an acute angle, we can say that this will end up being positive. So we can say it's going to be plus here, and we're going to go ahead and substitute cosine of beta in right here. Cosine of beta is 24 over 25, so it's going to replace this, so 24 over 25. All right, so positive 1 minus 24 over 25 over 2. Now we're going to want to simplify this numerator. We need a common denominator, so 1 is going to turn into 25 over 25. So 25 over 25 minus 24 over 25. This is going to end up being 1 over 25, and that all over 2 is going to continue. Now, this is a fraction within a fraction. So we're taking 1 over 25 and dividing it by 2. That's the same as 1 over 25 times 1/2. And so that turns this into the square root of 1 over 50. All right? And I can think about this as the square root of 1 divided by the square root of 50. And the square root of 1 we know to be 1. And the square root of 50 we can simplify to 5 square root of 2. And then I can actually rationalize this by multiplying by the square root of 2 over the square root of 2. And that would give me the square root of 2 over 5 times the square root of 2 times the square root of 2, which is the same as 5 times 2, which is 10. So our sine of beta over 2 is going to end up being the square root of 2 over 10. Now, for cosine, we're going to end up with something very similar. So let's walk through the process again. So the only thing that's different in this formula is what is the signage in front of the cosine. So this minus becomes this plus. So what we're going to see in the first two steps is going to look very similar. So that 1 plus 24 over 25 over 2 is going to become 25 over 25 plus 24 over 25 over 2. And then this 25 plus 24 becomes 49 over 25 over 2. All right. So again, 49 over 25 divided by 2 is the same as 49 over 25 times 1/2, otherwise known as 49 over 50. Still under that square root, still with a positive. All right, so the square root of 49 divided by 50. Now, we can think about this again as the square root of 49 over the square root of 50. When I do that, I can take the square root of 49, which is 7, and the square root of 50 simplifies to 5 square root of 2 again. And then I would rationalize that, multiply the numerator and the denominator by the square root of 2. So I'd have 7 times the square root of 2 all over 5 times the square root of 2 times the square root of 2, which is 5 times 2, which is 10. All right, so we know that now the cosine is 7 square root of 2 over 10. Tangent in this case is a little bit easier if we've already done this stuff. So let's take a look. We're really using this piece, 1 minus cosine of beta. So it's this 1 minus 24 over 25 here. Over this piece, 1 plus cosine of beta, which is 1 plus 24 over 25 in the denominator. Again, since this is an acute angle, tangent is going to be positive. And so let's see what that looks like. 1 minus 24 over 25, 1 plus 24 over 25. Change those ones into 25 over 25. So 25 over 25 minus 24 over 25. That becomes 1 over 25. And 25 over 25 plus 24 over 25, that's 49 over 25. All right, and remember that when you've got the same denominator, you can just multiply by that denominator, and you would just end up with 1 over 49. And then I can think of that as the square root of 1 divided by the square root of 49, which is going to be 1 over 7. And that wraps that one up. Okay, stay tuned. In the next video, we're going to talk about how to use these half angle and double angle formulas to verify. So we're going to take our verifying skills and take them just a little bit further. All right, see you then.